In 323, we're going to talk about derivatives of higher order when doing implicit differentiation. When we say higher order, we're referring to the second derivative or third derivative. So we need to come back to this notation, d squared y over dx squared, which means second derivative. And where that comes from is taking the derivative with respect to x of the derivative with respect to x of y. And now we can kind of see where the d squared comes from and where the dx squared comes from. No new vocabulary, no new rules or theorems here. So let's get started. We can say that implicit differentiation can also use to find derivatives of higher order. So our directions here to find d squared y over dx squared, the second derivative, if 2x cubed minus 3y squared is equal to 8. So let's rewrite that equation, 2x cubed minus 3y squared equals 8. And let's note that we're going to find the derivative with respect to x of both sides. So that's going to give us derivative with respect to x of 2x cubed, that'll be 6x squared. Derivative with respect to x of negative 3y squared will be minus 6y dy dx. And then on the right side, the derivative with respect to 8 is 0. Next, we'll move the 6x squared to the right side of the equation, and we'll have negative 6y dy dx is equal to negative 6x squared. We'll divide both sides of this by a negative 6y, and that'll give us a first derivative, dy dx, of x squared over y. So we have the first derivative, but we're after the second derivative. And to do that, we want to take the derivative of dy dx. So we want to differentiate both sides of the first derivative. That will give us the d squared y over dx squared that we're looking for. On the right side of the equation, the derivative of x squared over y will be found implicitly. Since that's a quotient of two functions, we'll use the quotient rule. So we begin with low times the derivative of the high function. So we want to go y times the derivative of the high function 2x minus, now we're going to go high d low. So the high function is x squared. Derivative of y is dy dx. And this is all over the low function squared, or y squared. We can clean that up a little bit, and we can also use the algebra of combining fractions and look at that as two separate terms. So this is 2xy over a y squared minus an x squared over y squared times a dy dx. This could be an okay answer, except for the fact that we don't want to give the second derivative result with a notation for a first derivative there when we already know what the first derivative is. Reminder, it's x squared over y. So let's do some more simplification. First of all, the y in the first term here in the numerator cancels with one of the two in the denominator. So that becomes 2x over y. Minus, we have an x squared over y squared, and we can substitute in place of the dy dx an x squared over y, since we know that's what dy dx is. And finally, that gives us a solution of 2x over y minus x to the fourth over y cubed as the second derivative, d squared y over dx squared.